Now we have dealt with the first principle, but we are going to use some examples to illustrate that first principle. The first one we are dealing with is to find the derivative, which is represented with y prime, or we have dy dx, or we call it f prime of s. These are the notation representing the differentiation of this function y, which depends on x. So we are looking for y prime of x from this first question given to us. From our first principle, we know that our dy dx is given by the limit as change in s approaches 0, f of s plus change in s minus f of x all over change in x. So what do we have? We are to get these two components, that is f of s plus change in s minus f of s. From our question, we know that y is f of x, and that is given to be what? S squared. This is the first component here. Now this one, which is f of s plus change in s, is equivalent to y plus change in y from our first principle explanation there. But what we actually need to understand here is that anywhere you see x from this one, you put these two things there, which is s plus change in s. Then this means s plus change in s squared from this first equation. So what we need to do is just to expand this. Then we have s plus change in x, s plus change in s. In our expansion, we can actually expand this using binomial expansion. But since this is the first one, we're going to use the normal, old school expansion. Then we have s times s, s squared, plus s change in s, which is s times s, s squared, s times change in s, s change in s, change in s times s, that is s change in s, then change in s times change in s plus change in s squared. Then we have it to be what? S squared plus 2s change in s plus change in s squared. Now we've gotten this component here and we've gotten this component here. So we substitute by saying the y, the s is the limit as change in s approaches 0. Then we have f of s plus change in s, that is this, s squared plus 2s change in s plus change in s squared, which is f of s plus change in s minus f of x, and my f of s is given to be what? S squared all over change in x. This s squared cancels s squared here. Then we have the limit change in x approaches 0. Then we have 2s change in s plus change in s squared all over what? Change in s. What this requires us to do is to put the limit of change in s as it approaches 0. But I'm telling you, before you apply any limit, you have to first divide. That means you can separate these two parts by saying this is 2s change in x divided by change in x plus change in s squared divided by change in x. Now what happens? This cancels this can also cancel this. Then we can now apply, the limit is still there, you have not made use of it. Then change in s, then we have 2s plus change in s. So we can now apply the limit here by substituting the limit, which will be 0 for change in s. There will not be any form of change in s. We have explained that initially. That will be 2s plus 0. Then we have 2x. So that means the derivative of y, which is f of x, which can be represented by y prime or f prime of x, or we call it the normal name dy dx, and that is equal to what? 2x. So this is the first example. We move to the next example. We have this question. You can undo that yourself, but I'm going to be dealing with this, which is y is equal to 3s squared minus s, using the first principle. We know the first principle to be what? The y, the x, equals to f of s, the limit as change in s approaches 0, f of s plus change in s minus f of x all over change in x. So what we have, we get the two components as I've explained initially. My f of x is the question you are given, which is 3s squared minus 2. My f of s plus change in x is going to be, anywhere you see x here, just put these two things. 3 into bracket s plus change in x, put the square that you have there, minus 2. Expand normally, then we have 3. Now, I've told you earlier on that you can use binomial expansion here, and that's what I'm going to be applying instead of the normal old school expansion. this one will be s squared plus 2s changing s plus changing s squared minus 2. The 2 is not part of this, it's outside. So we can expand the bracket by saying 3s squared plus 6s changing s plus 3 changing s squared minus 2. And that's what we have for our f of s plus changing x. So we substitute the two components up there. Then we have our dy dx equals to the lim. As changing s approaches 0, then we have 3s squared plus 6s changing s plus 3 changing s squared minus 2 minus my f of s, which is given to be, make sure you bracket it because the minus is expected to open the bracket here. 3s squared minus 2 all over what? Changing s. Be vigilant so that you won't make any mistake. Now, this one will be what? The lim. Let's deal with the numerator, numerator first. This one will be 3s squared plus 6s changing s plus 3 changing s squared minus 2. Use the negative to expand this. Minus 3s squared plus 2. Minus times minus is plus all over changing s. And we have the lim changing x approaches 0. Look at this now. Minus 3s squared cancel. Minus 2 plus 2 cancel. Then we have 6s changing s plus 3 changing s squared all over changing s. I've told you earlier on, before you apply the limit, make sure you divide. Then we have the lim changing x approaches 0, 6s changing x over changing x plus 3 changing x squared all over changing x. Then this gives, this cancel this cancel this. Then we have the lim changing x is 0. This is 6s plus 3 changing x. Applying the changing s, which will be used with this only, then we have 6s plus 3 into bracket 0. Then we have it to be what? 6s. And that will be our answer for differentiating. In conclusion, when you are differentiating from the first principle, all you just need to do is just to find the first two, the two components above here. Your f of s will be gotten from the question you are giving. Then f into bracket f plus changing s will be gotten by saying anywhere you see s, put s plus changing s, and that will be all. Then we are going to we will continue with the next aspect of it in the next phase.